Infinite series. I handed out a study guide for the exam. You should have a copy of that. If I didn't have enough copies there, just let me know. I can make more copies. But looking at the class, seems like I should have more than enough copies. I hope you wrote down the homework for section 11.2 last time. If you didn't, there it is. So once again, last time what we did is the following. We have the sequence AK given by AK. K is greater than or equal to 1. So the summation K going from 1 to infinity of AK is the same as the summation K going from 1 to infinity of K, which is 1 plus 2 plus 3 plus 4 plus dot 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 plus K plus dot dot dot. So this is given an infinite sequence AK, I can add up all the terms of the sequence, and that's an infinite series. If you are not careful with infinite series, you could be doing a lot of foolish stuff. So we have to be careful about what do we mean when we say that a series has a sum. You have to carefully define that. So let's go over a few examples first to understand how we should define the sum of a series. So if I have this series, then we said, well, let's look at the nth partial sum. What's the nth partial sum? Well, you look at the sum of the first n terms of the series. Look at the first n terms of the series. What you get is 1 plus 2 plus 3 dot 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 plus n. And what is that equal to? Well, we have a formula for that. That is n times n plus 1 over 2. And we have seen that formula in Calc 1. Those of you who are in math or stat, you will probably give a proof of this as an exercise in your foundations class. So we get that Sn is given by n times n plus 1 over 2, and notice that the limit as n goes to infinity of Sn then is infinity. And because the limit of Sn as n goes to infinity is infinity, we say that the series, or the infinite sum, 1 plus 2 plus 3 plus 4 plus dot dot dot, it's a divergent series, and more particularly we say that it diverges to infinity. So this sum, infinite sum, doesn't really make sense. It doesn't really have a sum. Similarly, if I look at the sum k going from 1 to infinity of minus k, that the series is negative 1, negative 2, negative 3, negative 4, negative dot dot dot, and this time the series diverges to negative infinity. So once again, the sum of this series doesn't make sense. Okay, there is no so this is a divergent series. Now let me give you an example of a convergent series. So let's say I have the number 1/3, and that's 0.33333 dot dot dot, and we can rewrite that as 0.3 plus 0.03 plus 0.003 plus 0.0003 plus dot dot dot, which is the same as 3 divided by 10, 3 over 10 squared, 3 over 10 cubed, 3 over 10 to the 4, and so on. So if I take bk to be the sequence given by 3 over 10 to the k, where k is larger than 1, then the summation k going from 1 to infinity of bk is the same as the summation k going from 1 to infinity of 3 over 10 to the k, which is 3 over 10 plus 3 over 10 squared, and so on. And it seems like this infinite sum, this series, should be equal to 1/3, right? Because remember, I started with 1/3, right? I started with 1/3, right? And found out that 1/3 should be equal to that series. So the sum of this series should be 1/3. But what does it mean that the sum of the series is 1/3? What do I mean by that? If I don't know what I mean by that, I might be doing a lot of bad stuff with it. Okay. So to make sense of this, well, we are going to take the nth partial sum of the series. So the summation k going from 1 up to n of 3 divided by 10 to the k. So that means we are truncating the series at the nth term. So I am getting rid of all the terms after the nth term and looking at the first n terms of the series. And that is 3 over 10, 3 over 10 squared, 3 over 10 to the n. So Sn is that. Nth partial sum of the series is given by that. Now, if there is any justice in the world, the limit of Sn better be 1/3. Right? Remember, I started with 1/3. I got the series. And then I'm saying the nth partial sum, if I add the first n terms of the series, I get this. And then, if there is justice, the limit better be 1/3. Well, let's see if it is. Well, Sn is 3 over 10, 3 over 10 squared, 3 over 10 cubed, plus 3 over 10 to the n. I am going to multiply both sides of this equation by 1 over 10. So you're multiplying by 1 over 10, so you get 1 over 10 Sn on the left. On the right side, if you multiply 3 over 10 by 1/10, what do you get? 3 over 10 squared. If you multiply 3 over 10 squared by 1/10, you get what? 3 over 10 cubed. So if you multiply 3 over 10 by 1/10, you get 3 over 10 squared. If you multiply 3 over 10 squared by 1/10, you get 3 over 10 cubed. What are you going to get next? 3 over 10 to the 4. When you multiply this guy by 1/10, you get 3 over 10 to the n plus 1. Okay? So now I'm going to subtract the second equation from the first. If I subtract the second equation from the first, what do I get? I get Sn minus 1/10 times Sn, right? Is everybody clear? On the left-hand side. On the right-hand side, notice all the terms will cancel out except for 3/10 and 3 over 10 to the n plus 1. Because all the terms in the middle, they will cancel out, right? 3 over 10 squared, 3 over 10 squared, 3 over 10 cubed, 3 over 10 cubed, right? They will all cancel out, right? All the way up to this guy, and then you're left with this one and this one. So I'm going to get 3/10 minus 3 over 10 to the n plus 1. Why minus? Because I'm subtracting, right? Okay. Now, what is Sn minus 1/10 Sn? Well, that is basically 9/10 Sn, right? 1 minus 1 over 10, that's 9/10. So I still have the same right-hand side. And finally, I'm going to solve for Sn. How would I solve for Sn? Multiply both sides by 10 and then divide by 9. So multiply both sides by 10, you get 3 minus 3 over 10 to the n, and then Sn would be 1/3 minus 1/3 1 over 10 to the n. So that is my Sn. Well, clearly, as n goes to infinity, what is happening to this guy? This guy is becoming 0. And so the limit of Sn is 1/3. Right? So there is justice in the world, at least in some cases. All right. So Sn has limit 1/3. So that's how I can make sense out of that. Okay. Okay. So in this case, we say that the series summation k going from 1 to infinity of 3 over 10 to the k is a convergent series, and we will say that it converges to 1/3, or we can say that 1/3 is the sum of the series. Okay. We write the series is equal to 1/3. You have to be careful how you are looking at that equality. Okay. Why? You have to understand what you're saying there. What you're saying is that if you take the limit as n goes to infinity of the summation of the first n terms, right? So k going from 1 up to n of 3 over 10 to the k. So if you take the limit of the sum of the first n terms, that is equal to 1/3, right? That's what it means by that equality. However, it doesn't mean that you can give me a value of n such that the sum k going from 1 up to 5 million or whatever you like, 500 let's say, of 3 over 10 to the k, you cannot give me a value of n such that this is equal to that 1/3. Am I making sense? That is, you cannot add up finitely many terms of the series and get 1/3. Am I making sense? So that equality, you have to understand what you're saying. You're not saying that if you add up finitely many terms of the series, enough many terms, you get 1/3. No. What you're saying is that the limit as n goes to infinity is 1/3. Okay? Okay, so as long as we understand that's what we mean, then we can put that equality sign there and say that 1/3 is the sum of that series. Okay, so finally let me be a little bit more formal. So what is a series? Given a infinite sequence ak, k greater than or equal to 1, if I add up the terms of the sequence, I get a series, right? So I'm adding up the terms of the series, of the sequence, I get a series. So summation k going from 1 to infinity of ak would be a1 plus a2 plus da 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 ak plus da da da. So the terms are coming from the sequence. You're adding up the sequence. So that's the infinite series, okay? When infinity is involved, there is always things are happening that are not as intuitive as in the finite case, okay? We'll see some examples in a bit. Let's look at the example of summation k going from 1 to infinity of 1 over 2 to the k. And what is that series? That series is 1 over 2 plus 1 over 2 squared, which would be 1 over 4. 1 over 2 cubed would be the third term, which is 1/8. 1 over 2 to the 4, that's 1 over 16, and so on. So that's an infinite series, and the kth term of the series is given by 1 over 2 to the k. 1 over 2 to the k is the kth term. Now, how do I make sense of it again? Well, I look at the nth partial sum, Sn. So what is the nth partial sum, Sn? It is half plus 1/4 plus 1/8 plus dot 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 plus 1 divided by 2 to the n. That's the last term. So 1 over 2 to the n, that's the last term of the partial sum. Now, can someone tell me what is S1? What is S1? S1 is what? Yeah, S1 is just half. What is S2? Half plus 1/4, the sum of the first two terms, which is equal to what? 0.75, right? What is S3? S3 is half plus 1/4 plus 1/8. And if you calculate that, you're going to get 0.875. Am I making sense? Now, you can use the calculator or ask a computer algebra system to compute the first 25 values of Sn. So S1, S2 up to S25. If you calculate all the way up to S25, this is the table you're going to get. So this is the table that you would be getting. Whoops. Where's the table? Right here. This is the table you would be getting. So S1 is 0.5, S2 is 0.75. What is S10? S10 is 0.9990234. What does it seem like? As n gets bigger and bigger, Sn is becoming what? Yeah, as n gets bigger and bigger, Sn gets closer and closer to 1. Seems like, right? It's not a proof, right? It just seems like that's happening. You would be you could be fooled by this a lot of the times, okay? I was discussing an example with Zach here on the board. In that case, if you look at the partial sums, the first few partial sums, it feels like it is converging, but it's not going to converge, okay? We'll see that. Okay, so it is, okay, now in this case, Sn is again a half plus a fourth plus a 1/8 plus 1 over 2 to the n. Now, Sn, I can show that Sn can be written as 1 minus 1 over 2 to the n. Okay? How did I get there? Okay, I'm not going to show the details here. All I have is that Sn is a half plus plus 1 over 2 to the n, right? And then what I'm going to do is multiply both sides by half. And if you do that, you get 1/4 plus plus 1 over 2 to the n plus 1. And then you're going to subtract and do whatever we did before. And you can come up with the formula that Sn has to be 1 minus 2 to the n. Now if you take the limit, 1 over 2 to the n goes to 0. So the limit of Sn is 1. So now I could say that the series k going from 1 to infinity of 1 over 2 to the k is equal to 1. Okay? The sum of the series is 1. Is everybody okay? The sum of the series is 1. Once again, let me tell you this equality, what does it mean here? Well, what it means is that if I take the limit as n goes to infinity, the summation k going from 1 up to n of 1 over 2 to the k, the limit of that is 1. Okay? The limit of that is 1. Okay, so we can say that this series is a convergent series. It converges to 1. Okay, so finally, we have a good definition of what does it mean to say that a series has sum equal to something. Okay, you have to have a good definition of what do you mean when you say that a series has a sum. Well, this is what we mean. Given a series AK, summation k going from 1 to infinity of AK, which is A1 plus A2 plus A3 let Sn be given by A1 plus A2 plus An in abbreviation, that's summation k going from 1 to n of AK. And this is called the nth partial sum of the series. This is the nth partial sum of the series. Okay? Let's say that L is a number. So if the limit as n goes to infinity of Sn, when you're taking the limit of Sn, you are taking the limit of A1 plus A2 plus An, right? So n is going to infinity. So that means as n goes to infinity, you're adding more and more terms. So the limit of Sn, if the limit of Sn is a number L, then we are going to say that the series is convergent. And we're going to say that L is the sum of the series. Okay? If the limit of Sn is a number L, then we're going to say that the series is convergent and the sum of the series is given by L. Okay? Let me know if you're done writing it down. You always have to keep this definition in your head. If you are dealing with a series without this definition, you could say many wild stuff, and I'm going to show you some examples of that. Okay. Now, whatever do in your life, right? If you are dealing with some concepts, if you don't know what exactly you are talking about, then you could be saying so many things. Okay. So that's why you have to have a good definition to begin with of what do you mean by a series. Okay. So what happens when the limit doesn't exist? When the limit of Sn doesn't exist, or it is infinity, or it is negative infinity, then we say that the series is divergent. Okay? We're going to say that the series is divergent if the limit doesn't exist as a number. So if the sequence of partial sums is divergent, then we say that the series is divergent. The sequence of partial sums is divergent means that the limit of Sn does not exist. And if the limit of Sn is infinity, we say that the series diverges to infinity. If the limit of Sn is negative infinity, we say that the series diverges to negative infinity. Is everybody okay? So now we have a definition of what it means to say that a series has a sum. What is the essence of everything that we said? The essence of everything that we said is right here. The essence is what is the meaning of a series, infinite series, k going from 1 to infinity of ak? The meaning of that series is that it is the limit as n goes to infinity of the sum of the first n terms, right? So the nth partial sum, you take the limit of the nth partial sum, and that's the meaning of the series. If the limit doesn't exist, the series doesn't make sense. If the limit exists as a number, then that's the sum of the series. Okay? Am I making sense? If the limit is a number, then the infinite sum is defined. If the limit does not exist, then the infinite sum is undefined. Now, so let me give you a example and what can happen if you're not thinking about your definition. Okay. So let's consider this series. 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus. What are the terms of the series? The terms of the series are all 1. They are all 1 alternating in signs, right? Now, let's do the following, okay? I am going to group together these terms. What is happening then? What am I getting? 0, 0, 0, 0. So what's the sum then? Okay, so we got that the sum of this series is 0 in this way, right? So let me delete what I did. And let's think about doing something else. Let's say now I'm going to group together. I am not going to do anything with the first number 1. The first term, I'm going to isolate that. And then I'm going to group together the next 2, the next 2, the next 2, the next 2, and so on. So what's happening now? I'm getting 1, and then 0, 0, 0, 0, 0, right? What am I getting now? 0 is equal to 1. Yeah. And the question is, that's what I'm saying, that if you are not careful, if you have to start with your definition. If you are forgetting about your definition, you can say a lot of different things. Okay? A lot of different things can be said. Not only I can get 1, I can actually get 4 out of it, depending on how I am arranging it. I can get 1 million out of it, depending on how I am arranging the terms. The question is, am I allowed to arrange the terms like this? The answer is no. What's the definition of a series? So let's now think about the definition of the series so that we are not doing anything illogical here. So let's think about what is the nth partial sum of this series. The nth partial sum, however, I'm going to look at the even partial terms and the odd partial sums. Okay. So what is the nth partial sum? The nth partial sum is basically 1 minus 1 plus 1 minus 1 plus ... What's the last term? It will be 1, but multiplied with what? Negative 1 to the what? Plus 1 or minus 1, right? The first one is positive, so I need n to the first one would be, let's write n minus 1. So if n is 1, you get positive. So then multiplied by 1. Now, can someone tell me what is that when n is even? And what is that when n is odd? Well, do some examples. Look at S2, S4, S6. Look at S3, S5. Can someone tell me what you're getting? Go ahead and write down. What is S4? Go ahead. Look at S4. What is S4? 0. What is S5? You agree? 1, yeah, 1. Is everybody okay with that? So depending on whether n is even or odd, so let me make sure I write it down again. So what is, for example, S4? S4 would be 1 minus 1 plus 1 minus 1, right? 4 terms. Do I get 0? Yes. So are you going to get 0 for S6? Yeah, for all the even, whenever n is even, you're going to get 0. Now, what is S5? S5 is S4 plus 1, right? Which is going to be 1, right? So, what's the limit of Sn? The limit of Sn is what? Does not exist, right? Sometimes it has. If you look at the sequence Sn, it's 0, 1, 0, 1, 0, 1, 0, 1. So it doesn't have a limit. So this series that I have, right, it doesn't make sense. It is divergent, right? It is divergent. Its sum is undefined. Okay, it has undefined sum. Am I making sense? So point is, if you're not thinking about your definition, you could say a whole lot of things that might, for a second, seem like very, very logical, right? But it's not the case. Am I making sense? There are other examples that things will happen like this. Now, one thing that is important, when you are adding, when you have an infinite series, you are not allowed to rearrange the terms or group together the terms. Is everybody clear? Okay, so let's look at a geometric series. What is a geometric series? A geometric series is like this. Summation k going from 1 to infinity, a multiplied with r to the k minus 1. A and r, these are constants here. A and r. So what is that series then? Well, when k is 1, you get a. When k is 2, you get AR. When k is 3, you get ar squared, and so on. Right? Is everybody okay with that? Now notice that every term has a factor of a, and the ratio of any given term to its previous term is always r. The ratio of any given term to its previous term is always r. That is, for example, if you divide ar cubed by the previous term ar squared, what do you get? R. If you divide ar squared by ar, you get r as well. So what I'm saying is that look at the ratio of any term to its previous term, you always get r. R is called the common ratio. So how are you getting the next term? The next term you're always multiplying by r, right? The next term you're always multiplying by r, right? A multiplied by r, you get the second one, multiplied by r, you get the third one, multiplied by r, you get the fourth one, and so on. Right? What is the nth partial sum? What is the nth partial sum of the geometric series? Well, the nth partial sum would be the summation k going from 1 to n, a r to the k minus 1. So what's the nth term? The nth term would be a r to the n minus 1. So that would be the last term of the partial sum. So Sn for the geometric series is that. Is everybody okay? Everyone's okay with that? Now, I want to figure out for what values of a and r is the geometric series convergent, and for what values of a and r is the geometric series divergent. Is everybody clear? Okay, so let's think about the case when r is 1. When r is 1, what can you say about Sn? What can you say about Sn when r is 1? Well, when r is 1, Sn is what? A plus A plus A plus dot 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 plus A. How many A's? How many A's? N. So Sn when r is 1 is just n multiplied with a. So what is happening as n goes to infinity? What is happening to Sn as n goes to infinity? Well, as n goes to infinity, Sn is either going to infinity or it's going to negative infinity, according as what? According as the sign of a, right? If a is positive, then Sn will go to infinity. If a is negative, Sn will go to negative infinity. You guys agree with that? You guys agree with that? Because I have Sn. Sn is equal to n times a, right? N times a. So when a is negative, n times a will go to negative infinity. When a is positive, n times a will go to positive infinity. So the limit of Sn, in either case, it is divergent, right? So Sn is divergent. Therefore, the geometric series diverges when r is 1. When r is 1, the sum of the geometric series is undefined. Is that clear? Okay, so now we want to look at the case when r is not 1. Assume that r is not 1. So what can I say in this case? R is not 1. So let's think about what is Sn again. Sn is a plus a times r plus a times r squared plus dot 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 plus a times r to the n minus 2 plus a times r to the n minus 1, right? The last term is a times r to the n minus 1. Now, the trick is multiply both sides by the common ratio r. So r times Sn What is that? It is going to be, when you multiply A by R, you get AR. So you're multiplying A by R, you get AR. When you multiply AR by R, you get AR squared. So this is what you get. Plus AR cubed when you multiply this by R. Plus dot dot dot. Plus when you multiply this guy by R, you get A R to the n minus 1, and when you multiply this guy by R, you get A R to the n. Is everybody okay? Now I'm going to subtract. If you subtract, what do you get? You get Sn minus R times Sn. What is left on the right hand side when you subtract? A minus A R to the n. Okay, so if you believe that, then I can factor out Sn here, and I get 1 minus R times Sn. And here I'm going to factor out A. I'm going to get 1 minus R to the n. And finally I could say that Sn is equal to what? A divided by 1 minus R multiplied with 1 minus R to the n. You agree with that? I'm dividing both sides by 1 minus R. Now we are going to look at the limit of Sn as n goes to infinity. Now, remember R is not 1, right? R is not 1. So that's why I could divide by 1 minus R, right? Otherwise it doesn't make sense. Now, do we understand this sequence very well now? R to the n. Remember the last thing that we did in sequences was we talked about the sequence R to the n. Let me show you what we said last time about this sequence. About this sequence we said the following, right? The sequence R to the n is convergent if R is between -1 and 1, and it is divergent for any other values of R, right? R to the n is convergent when R is between -1 and 1, and it is divergent otherwise. Not only that, we also know the limit. The limit of R to the n is 0 when R is between -1 and 1. Right? So we're going to use that. We're going to use that today to say that now I could say that the limit of Sn as n goes to infinity is A divided by 1 minus R times 1 minus 0 as long as R is between 1 and -1, right? When R is equal to 1, we already have seen that the geometric series is divergent, so I don't care about what happens when R is equal to 1. However, if R is outside of this interval, then we know what? R to the n is divergent, right? So, otherwise it is divergent if R is well, let me just say absolute value of R is bigger than 1. Absolute value of R is bigger than 1, it simply means that R is beyond the interval from -1 to 1, right? So we know that R to the n is divergent when absolute value of R is bigger than 1. And R to the n is 0, goes to 0 when R is between -1 and 1. So now we know exactly when the geometric series converges, and if it converges, we know what's the sum. What is the sum of the geometric series then? A divided by 1 minus R, right? Because I have just 1 minus 0 here. So the summation of the series, geometric series, has sum A over 1 minus R. So let me recap everything that we did in a table. The geometric series, summation k going from well, I wrote n here. So n going from 1 to infinity of ar to the n minus 1, a plus ar squared plus dot dot dot, and so on. I know this is, I copied it from the text, so that's why their notation is they are using n, I was using k. Is convergent if the absolute value of r is less than 1. Remember, absolute value of r less than 1, what does it mean? It means that r is between -1 and 1. Right? And in that case, the sum of the geometric series is a over 1 minus r. Otherwise, when the absolute value of r is bigger than 1, the series is divergent. The geometric series is divergent. The sum is undefined in that case. Geometric series is the simplest series. However, it is used a lot. Okay, even if you look into a finance book. Zach, did you take theory of interest? You might be seeing the geometric series there. So it is used a lot, however, it's really a simple series. Okay, and we are going to see a bunch of examples of this in a bit today, or maybe another time. But let me give you another result which is very important. If the series AN, actually, let me give you an example first of a geometric series. Otherwise, okay. So let me. Otherwise, I feel like I'm cheating here. So this is, let's say, k going from 1 to infinity. Let's take a geometric series. Let's say, I don't know. Let's say 2 divided by 3. You know what? Let me first use a simple case here. Let's say half to the k minus 1. No, let me use just k. How is that? K minus 1 was easier, but let's make it k. Okay, what is the sum? Can someone tell me by looking at what we said in that box, and tell me what is the. First of all, is this series a geometric series? How do I know it's a geometric series? Well, let's write it out. Let's write out some of the terms, right? Half 1 over 4, 1 over 8, 1 over 16, dot dot dot. Now, someone tell me, should this be called a geometric series? Why? Why should I call it geometric series? What is that? Yeah, if you look at the terms, determine the following. If you divide any term by the previous, what do you get? Divide any term by the previous, what do you get? Half. Divide 1/8 by 1/4, what do you get? Half. So you know that the common ratio here is half. The mistake that you can make is that you might be dividing 1/4 by 1/8. Then you're going to get what? 2. That's a mistake, because then the ratio is bigger than 1. So now divide any term by the previous, see if you get a common ratio. So the common ratio here is half. So this is a geometric series, right? What is A here? One half. A, remember, was the first term, right? Now, if you look at this and this, what's the difference? When I wrote the thing in box, I'm using the exponent to be k minus 1, right? K starts at 1. But here, what do I have? I have half to the k. If I want, I can make it look like that. I can just write it as k going from 1 to infinity, half times half to the k minus 1. Then is it obvious that a is half? Even if you don't know that, it's better to just write it out. Whatever the first term is, that's a. And then the common ratio is half, right? And then you apply your formula for the sum, right? So what's the sum? So this is equal to what? A half divided by what? 1 minus r, which is 1 minus half. And what am I getting? Am I getting 1? Remember, this is what I got before too, when I talked about this before. Is everybody okay with that? Okay, let's do another example. Let's say I have the summation k going from 1 to infinity, 3 to the k plus 1 divided by 2 to the n. Sorry, 2 to the k. What is that? Is that a geometric series? Is that a geometric series? Well, the best thing to do is figure out what's going on with the terms. Okay. So well, first of all, the way I'm going to think of this is I'm going to think of this as k going from 1 to infinity 3 times 3 to the k divided by 2, like this. Can I think of this like this? You guys agree with that? And then I can also say the following: k going from 1 to infinity. Well, I don't even really have to say anything else. Let's take the 3 outside. I don't really have to, but is it a geometric series now? And what's the common ratio? Is it bigger than 1? It's divergent then, right? So divergent. Am I making sense? Okay, so I did sloppy work here, but I'm going to do a lot more examples next time to illustrate how to use the geometric series. Okay.